Okay, today's lesson will be on the second mode of heat transfer, but it will be on convection. The definition of convection transfer is actually in the book or in most of the notes that we have. Okay, one of the things that we need to pay attention is in convection is that this particular mode of heat transfer actually involves the movement of the fluid itself. The medium itself, is either liquid or gas, it actually moves in the process of transferring the heat. Okay, and the process of movement is actually due to the differences in density. Okay, we will talk more about the exact mechanism involved in convection. But one of the things to take note between the first mode of heat transfer, conduction, versus this particular mode of heat transfer, convection, is that for convection, the medium actually moves. Okay, whereas the first mode, conduction, the medium itself, it actually doesn't really move. Okay, so this is one of the things that students need to actually subconsciously make a distinction between them. Okay, in conduction, it doesn't move, the object. In convection, the object or the medium actually moves. Okay, and one of the other difference that we are looking at is that for convection, we are actually dealing with two types of medium, mainly liquid and gas. Whereas in conduction, the medium that we are actually looking at is actually all the three particular states of solid, liquid, and gas. Okay, so please note the difference for students. Okay, how convection current works is actually through the differences in density. How does it work is that, for example, the water at the bottom area, okay, when it's being heated up, it actually do what we learned in our primary schools or our grade 4 or grade 5 sciences. It actually tells us that all metals upon heating, it actually expands. So when it expands, what we have in terms of density, which is mass over volume, okay, when it expands, the volume increases. As a result, the density of the object actually decreases slightly. And what's the difference now? With the decrease in density, the substances actually will start to float up. Okay, move upwards, it will start to float. And at the same time, the object or the liquids or the fluids at the above side, which is still the same or actually colder, or in fact the density is higher than the hot fluid, what it does is that the cold substances will actually sink down. Okay, because the density now is actually relatively higher. So what you have is that the hot will rise and the cold will sink. So if you repeat this cycle whereby the cold fluid actually gets heated up and it becomes less dense and it float up, the cold substances being denser will sink down. Okay, and this cycle when it repeats, and this cycle is what we call a convection current. And this process is namely what we have in this particular mode of heat transfer, the convection current. Okay, now for students, I would say the understanding for convection current is not a complicated issue. Most of the time, the problems that students face is actually writing convection current in a clear manner that the markers actually understand them. So what I did is I actually break down the convection current into three particular keywords or three particular sections. Each section will have its own tagging keywords, and when you make up all the three sections with the correct keywords, I will say that it will give a perfect meaning or representation of your understanding of convection current. So what does it encompass? In the first section, we talk about the hot region. When we talk about hot region, the primary focus that we are looking at is actually the object actually get heated up. So when it gets heated up, the first keyword that we are looking at is that the marker or the students will have to mention that either the volume increases or the substances actually expands. So that would be the first keyword that we are dealing with. After expansion, the density of the object will actually decreases. So this will be the second set of keywords for this particular section. And with a less dense density, the region will actually do what we understand, it will actually rise up. Okay, so in the first section, we're talking about the hot region, and this hot region we actually includes expansion, less dense, followed by rise. So in this particular section, I have actually three key terms that is tagged to it. Okay, and these 3 key terms form what we call keywords for this particular section. For the second section here, we look at will be the co-region. So the co-region is slightly straightforward because we actually mention the changes in density, changes in volume. So in the second section here, the co-region, what we need to do is just to tell the marker that the cold region is actually much denser as compared to the hot region. And what it does is it actually will sink down. So primarily the first 2 sections actually focus on the hot rising up and the cold sinking down. Okay, so you have this up-down process, but the important thing is not the up-down process. The important thing is highlight to the markers that the up and down process, the rise and sink, is actually due to the differences in density. So that's why in the 2 section, the 2 keywords, the tagging key terms that we're looking at is involve mentioning of the changes in volume, changes in densities. Okay, and the third keyword, which is the easiest, you have to tell the marker that the cycle actually repeats and a particular system is actually set up, and that system is called convection current. So what I've done is actually group them into 3 sections. So the first section is the hot region, the second section here will be the cold region, and the third section will be the formation of convection current. And bear in mind, at each section there are tagging key terms, okay, to form what we call the keywords in each section. Okay, despite that the fact that you need to write a bit, the marks allocated is actually quite minimum. Main reason is that the concept behind is not complicated. It's not worth having more than 3 marks for this particular section. Okay, but the good thing about for these sections, the idea is actually quite standard. Okay, it's just that students need to actually grasp the whole of the main process, whether is it a convection or is it a conduction process. Okay, the same 3 sections we can actually apply to other situations. Now we look at convection in gas. Same thing, what we have is I have a candle, okay, which is burning below a chimney, B. So what we have now is that the air near the candle here will actually get heated up. So it will rise up. And the cold region here, and the cold gas, or the cold air that we have, okay, the cold will actually sink down. Okay, will actually sink down to take the place. Oh, you might not be able to see the marker. Okay, let me change my color first. Okay, so the cold one, okay, I hope this is better. So the cold air will actually come down, sink down to take the place. So the process what we have is the hot will rise, the cold will sink. So in understanding, it's really quite basic. If you talk about convection current, it's primarily the main idea is hot rise and cold sink. Okay, but how about the keywords that we are looking at? For the keywords, it will be still the same 3 sections, whereby I talk about the hot section, whereby I talk about expansion first, and I talk about less dense, and after that I will state the outcome, whereby the air actually rises up. That will be the first section here. The second section will be the same. I talk about the cold region, whereby the air being colder, which being relatively denser in density, will now actually sink down to the chimney A to take the place of the hot region. So 1 and 2, you combine them, you repeat it, and you actually form the third section whereby a cycle is actually being formed. So this cycle that we are looking for is convection currents. Okay, so this is what we mean by presenting the answers or presenting the concepts to your markers to gain to answer the questions. Okay, and in fact, these 3 are the classic examples, and there are more examples, much more examples outside, or much more examples in real life that we can actually use. But once we identify the concept behind it, you'll find that most of the devices or most applications that involve convection current actually can be explained using the three sections here that I listed in the previous 2 slides. Likewise for land breeze and sea breeze, a classic example where you see in science and geography, okay, whereby breeze coming from the land and breeze coming from the sea at different timing. It actually involves the cold air rising, the hot air rising, okay, the hot air rises, and the cold air sinking, being denser. What it actually happens is that at different part of the day, daytime and nighttime, the hot air from different areas, either the sea or the land, okay, will perform the same convection current. The hot air will actually rise up. In the daytime, what we have is that the hot air actually occur at the land side. Okay, the hot air from the land will rise up. The cold air, being denser from the sea, will actually sink down to take its place. And for the night time, the same concept will appear. The hot air will rise, but now the hot air actually take place at the seaside. Okay, so at the seaside, we have the same thing. The hot air will rise. The cold air now is at the land side, will sink, being denser. And you have what we call the land breeze taking place at the night, sea breeze taking place in the daytime. If you look at the idea or the writing or the keywords behind land breeze and sea breeze, it still goes back to the same three sections that I listed in the previous slides. The first section, we talk about the hot area. The second slide, we talk about the cold area. And when we talk about section 1 and section 2, cold and hot and cold area, bear in mind you have to write down the tagging key terms, the density changes, the expansion, the volume, and the action, the rise or the sink. Okay, for the cold and the hot region respectively. And the third section that we are looking at is formation of the cycle, what we call the convection currents. Okay, so it still goes back to the same three sections which I listed in the previous three slides. So what I have done here is actually I classified convections, I termed convection into a simple three-step process so that students will actually have an easier time grasping the explanations, giving the correct keywords in exam, getting their marks, getting their grades, getting their correct grades that they deserve it. Okay, so bear in mind, okay, the three tagging keywords are the three tagging sections. The keywords are listed here. The first section, second section, okay, and the first section. Give me a minute. Okay, so we have the first section here. So we have the first section, we deal with the hot, and we have the second section whereby we deal with the cold. Okay, remember in these two sections, it's important to follow, to note the keywords. For the hot section, we actually includes the changes in volume, followed by the density and the action. For the cold section, we just include density and the action. Okay. And finally, we have the third section whereby we listed down the system that has been set up. The system we are looking at here is known as convection currents. Okay, I do hope this way of listing the answers actually might be clearer or might be easier for all the students to actually take up. Okay, to know what the markers are doing, to know how convection current can be easily explained and understand. Okay. Okay, if you have any comments or feedback, okay, feel free to leave them at the comment section at the bottom. Okay, if you want to get the latest update on my video, okay, feel free to click the subscribe button at the bottom and activate the notification bell also. Okay, so see you soon. Bye bye.